Hi, my students. Today we will complete lesson 6.5. Last time we solved many many balanced chemical equations. Today we will know how can we write the formula of any compound. Before starting, let us make a quick revision about the periodic table. As you know that the periodic table has 8 groups. Groups means lines, and 7 periods. Periods means rows. So 1, 2, group 2, group 3, 4, 5, 6, 7, 8. So it has 8 periods and 7 lines. Line number 1, 2, 3, 4, 5, 6, and 7. We cannot count these 2 lines. These are lanthanides and actinides that are related to period 6, lanthanide, and period 7, actinide. So they are not a new lines or new periods in our periodic table. Actually, they are related to period 6 and 7. And we said that the elements that are in the center of the periodic table, that yellow color, called a transition metals, or called the transition metals, that they are metals, but they are less reactive than group number 1 and 2 and 3. So the metals that are in group 1 and 2 and 3 are much more reactive than the metals that are found in the center of the periodic table. From group 4 till the end are mostly non-metals. Why we said mostly? Because lead is in group number 4, but it's a metal. Tin is in group number 4. Sn means tin is in group number 4, and it is also a metal. But mostly group number 4, 5, 6, and 7 till 8 are non-metals. The left side of the periodic table non-metals, while the right side is non-metals, while the left side is metal. And we said also the number of the group decides the number of the elements that are found in the last shell or in the valence shell. For example, fluorine is in group number 7. So without knowing its atomic number, it has 7 electrons in the outer shell. Phosphorus, for example, is in group number 5. Without distributing its atomic number in shells, phosphorus has 5 electrons in its outer shell. Let us choose a big number like, francium, for example. Fr. Francium, for example, has 1 electron in its outer shell because it's in group number 1. Don't care about its 87 electrons or 87 protons, and we said before protons equals electrons. Don't worry about all of these things because simply the final shell is 1. Or the electrons in the outer shell equals 1. Even here, lead, for example. Lead is in group number 4, so it has 4 electrons in the outer shell. What is the benefit of all of this? The number of the electrons in the outer shell tell us what is the valency of this element. What does this mean? What is the meaning of valency? Valency means the number of the electrons that may be gained or lost. Why? To change or to let the atom to be neutral or to let the atom to be satisfied. So any atom wants to gain or to lose electrons to be stable, to be satisfied, or to have the lowest amount of energy. That's why metals and non-metals doing chemical reactions, because some metals want to gain and some metals want to lose. Which one wants to gain and which one wants to lose? we will know it now by summarizing them in a table. But in general, before starting before start drawing the tables, in general, group number 1 and 2 and 3, because they have 1 and 2 and 3 electrons in their outer shells, they always want to lose electrons. They don't want these 1 or 2 or 3 electrons. But imagine another thing. Imagine that you have 1 GD and your brother has 7 GDs, for example. And you saw a chocolate in the mall. Its price is 8 GDs. Which is easier for both of you? To give your 1 GD to your brother, which has 7 GDs, so that the total number of the money will be 8 to buy this chocolate, or your brother will give you his 8 GD or his 7 GDs, so that you have 1 GD plus 7 from your brother, so the total number of the money will be 8. Okay, the result, the final answer is 8 in both cases, but it's much easier for you to lose your 1 GDs, but your brother will not give you his 7 GDs. This is the same thing for an atom, for any atom. It's easier for an atom to lose 1 or 2 or 3 electrons, but the atoms that have 7 electrons in its outer shell, like fluorine, it's an atom that is in group number 7, so it has 7 electrons in its outer shell. So fluorine and chlorine, bromine, iodine, astatine have 7 electrons in it, in their outer shell. So it's very difficult for them to lose their electrons. Instead, they will gain. For example, group number 1 elements like lithium has 1 electron in the outer shell because it's in group number 1. Fluorine has 7 electrons in the outer shell because it's in group number 7. Fluorine wants to gain 1 to be 8, and lithium wants to lose this one. It doesn't want it. So lithium will lose it easily, and fluorine wants to gain it. So the electron that maybe lithium wants to lose it, fluorine can accept it easily. But why 8? Why not 10? Why not other number? Because all these elements, metals are not metals, wants to be like the electronic configuration or the electronic structures of the noble gases. All of them. So any of these metals or even non-metals want to have 8 electrons in their outer shells, or their structures, electronic structures, look like the electronic structures of the noble gases. So fluorine, it has 7 electrons in the outer shell. Whatever is the inner shell, I don't care about it. The last shell is 7. After gaining 1 electron from any atom, it will be 8. So by this case, its electronic configuration or structure in the outer shell will be 8, which is exactly looks like the neon, which is a noble gas, which has 8 electrons in its outer shell. This is the concept of the chemical reaction. That's why atoms want to gain or to lose electrons, to look like the electronic structure of the noble gases. That's it. Let us summarize this.